Okay, let's have a look at electrostatics. To do that, we need to have a look at a model of an atom. So at the centre of our atom we have our nucleus, which is made up of protons and neutrons. The protons are positively charged, the neutrons are neutrally charged, and surrounding this we have electrons, which are negatively charged. So an atom with an equal number of protons and electrons, positives and negatives, will be what we call neutrally charged. We can then say if it has an excess of electrons, so an excess of negative charges, that this atom will have a negative charge overall. If it has a deficiency of electrons, so less electrons than protons, then our atom will be positively charged. In other words, it's got less negative than positive, therefore it has an overall positive charge. We can also say this about objects as well. So objects can be what's called positively charged, negatively charged, and if the number of protons and electrons are equal, then it can be what we call neutral in charge as well. So what's this concept of charge and how do we measure it? Well, we measure it in a unit called Coulombs, which is given the symbol capital C, and we define 1 Coulomb as the charge on 6.25 by 10 to the 18 electrons. So this allows us to say that the charge on 1 electron is 1.6 by 10 to the minus 19 coulombs. And you'll notice I've put a negative sign in there. Because an electron is negatively charged, we denote this number as minus 1.6 by 10 to the minus 19. We can then say that the charge on 1 proton, because the charge is equal, it's going to be equal and oppositely charged, so it's going to be positive 1.6 by 10 to the minus 19 coulombs as well. So same number, opposite sign. Now one other definition that we can also say is that if we're looking at current, which is also a measure of charge per unit time, 1 ampere, which we denote symbol I for, is 1 coulomb of charge per second. So I equals our charge per unit time.